So far, we learned how to create a RESTful web service with the different sets of HTTP methods such as get, post, put, and delete. And we have performed unit test cases and integration test cases as well. Now let's see how we can secure our REST endpoint. I'm talking about the secured communication between the client and the server. I'm not talking about authorizations. Let's look at how we can secure the communication between the client, such as from the postman or the curl command to the server, which is Spring Boot server itself. For that, first we need to create a self-signed certificate and we need to configure it in the Spring Boot. So we can create the self-signed certificate using two tools. One is a Java tool, which is a key tool, and another one is OpenSSL. In this tutorial, we are going to look at how to create self-signed certificate using key tool, which is a Java provided key tool. And as part of the Spring Boot application, we need to configure a key store in the application.properties. We need to provide password and the alias because key store can hold more than one certificate. So let's see how we are going to create a key store and a self-signed certificate or the key for Spring Boot application. I'm in Eclipse and I have opened terminal. Let's maximize it. I'm creating local terminal. So let's check first of all whether we have key tool configured in our path or not. Key tool is configured in path. Key tool is part of our JRE or our JDK version. In my local, when I run the key tool, it is launching from STS itself, but the same is available at Java library as well, which means JDK. So let's check it. As part of here, we have the JDK 19 and let's see in the bin. In the bin also, we have key tool. It's the same key tool that is being provided. Of course, it is having different sets of versions as per the JDK, but the commands and the arguments is the same across all the versions. So you can use key tool from the STS or from the JDK itself. So key tool is provided as part of the bin. Let's copy the same. Let's clear the console. I'm setting the path. First, I'm setting our key tool and then I'm giving the rest of the path. With this configuration, we will get key tool from the JDK. So let's run where key tool. We see it now, it is picking up from JDK. Let's go to our project location. So in our case, so I'm copying the path. So let's clear the console. Let's run the key tool. Key tool -h, which provides the help, will be generating the key using generate key pair. But let's see the help for it. So as part of it, what are the things that we need to pass? First of all, we are going to pass the alias. So in this case, it is a tutorial. The next one is algorithm. In this case, it's RSA algorithm. I'm going to provide the key size as 2048. Store type PKCS12. And we need to provide where the key store needs to be created. So I'm giving the key store and I'm giving the name as Spring Rest SSL.jks Java key store. And we need to provide key store password as well. So store password. I'm giving password as a password. And the final thing is the validity. So we can give our validity for a day or for 10 years or anything. We just need to mention in number of days. So I'm giving validity as 7 days. So let's hit the enter. As part of it, it would be asking few information. So first and last name, I'm giving my first and last name. And name of the organization unit. So for now, I'm saying learning, and the organization doing is learning. This is just for the namesake, and city and the state and country code. So once everything is okay, type yes to generate the key store. Now just now it created the entire key store with our key. Our key is tutorial and the key store is Spring Rest SSL JKS. How are you going to verify what keys that the key store contains? Key tool, and as part of it we can say list. So it's going to list all the entries. So I'm going to give hyphen list. Let's check the help. So as part of it, we need to give our key store, which is Spring Rest SSL, and I need to give the password also. Either we give the password or it's going to list out asking for the password. So I'm typing the password. Now as part of it mentioned that it contains one entry and key store type is PKCS 12 and it was created by Sun, which is nothing but the JDK. So this is our key and it was when it was created and it's the certificate fingerprint. So how are you going to see whole data that's using the verbose? By providing -v. Type the password. Now it's going to list out all the information about the key store and how many keys that it contains. So if we see it, it's the same. One key is present and it has the alias and when it was created and who is the owner and who is the issuer. In my case, it's a self-signed certificate. That's the reason I'm the one who is issued it. But in real life, it will be issued by external parties such as GoDaddy or any other one. From where to where it validates. So I give in 7 days. So that's why it says until March 3rd. And the algorithm is RSA and its key size is 2048 as we provided. So all we need to do is now copy this one into our resources folder and configure all the information such as key store password and our alias. In our case, the key is tutorial. Let's configure the same and check. I have copied the JKS file into the SRC main resources. Let's configure the application.properties. So as part of it, first, let's configure the port. Here it's a secured, so instead of by default, it would be 8080. Now, as it is secured, I'm providing 8443. Now we need to configure SSL. So server.ssl. Here is all the information. Our key alias, as I mentioned, it is a tutorial. You can see it here. It's a tutorial. And the next server.ssl. The key store, in this case, key store is for the path. So I'm saying class path. Inside the class path, I'm saying Spring Rest SSL. And the next one is SSL.enabled. So I'm saying enable it. And now we need to provide server.ssl.key store type. In our case, our store type is PKCS 12, and we need to provide our key password as well as we have set the password. So in our case, password is a password. Save all of them and start the application. Let me start the application. So it says that key store password is incorrect. We configured the key password, not the key store. So we need to provide key store pass. So which is key store password. So let's rerun the application. This time it would be success. So it started. Now let's open our welcome controller so we can see. So we need to configure HTTPS //localhost 8443 and API v1. After hitting it, now we are getting the response from the server, but this time it says that connection isn't private. This is being given by our browser. Click on this one. Here it says that certificate authority is invalid because this is self-signed certificate. If it is a real certificate, then authority would have been allowed it. For example, if we create the certificate from the GoDaddy or any other certificate providers, then it would have been valid. So in this case, you can see it, who got it and who is the issuer and when it's going to expire and when it is created, and it's a certificate fingerprint. So let's click on the not secure, and here you can see connection isn't secure. Click on it and here you see a certificate icon. Click on it. It provides all the information about the certificate. So in this case, organization and department and who issued it, which organization is it, all the information has been provided. Now let's click on the advanced and continue to the localhost. It says unsafe because it's a self-signed certificate. That's the reason. But in our case, we can just click on it. So we got the response from the server that it is saying that welcome user as expected. Okay, now let's run the unit test cases and integration test cases just to ensure nothing has been broken. So I'm running it. I'm running the test cases. Now if we see it, all unit test case has been passed, but the integration test case has been failed. So let's see the reason for the failure. And the reason for the failure is here it says that unsupported or unrecognized SSL message. Because now HTTPS secured communication has been enabled. So that's the reason we are getting this error. So how are you going to fix this? As it's a self-signed certificate or the keys or key store, so we need to configure the trust store as well, which means this is valid one, just to ensure that this is a valid communication, like in the real time. If we have used the real issued certificate or a real key, then this problem would not occur. As we are using the self-signed certificate, so that's the reason we got it. All we need to do is, or while submitting the request using the Rust template, we just need to trust it that the certificate is valid. Enable the SSL authentication or validation against our self-signed certificate. Let's open the resources and copy the same key as it is in the main resources. So I copied the same one and go to the application.properties. I have copied exactly the same as main sources of application.properties. The difference is I have not copied the port. All the properties are not required. All we need is key store and the key store password. So remaining we can ignore it. So I'm removing it. Alias is not required. Store type is also not required because by default we are enabling for the Java key store itself. And after that, all we need to do is load this Java key store and create REST template to enable or to verify against the given Java key store. To make SSL test case, so all we need to do is we need to update this REST template. Internally, it calls a HTTP client, and on the HTTP client, we need to set SSL context with the JKS file. Before we start the implementation, we need to add one more dependency to set up the SSL context on HTTP client through REST template. Now to access the SSL context and setting our key at the REST template, we need to use another dependency which is HTTP client. So for that, I have added HTTP client version 5. So this is part of the org Apache HTTP component and client file. So I added the dependency and updated the POM file as well. Now let's set the SSL context. So how can we do it? So let's create void setup. And this will be called only once because the REST template is at the class level. So that's the reason. So I'm calling before all. So as part of the setup, first we need to capture the key store and the key store password. So let's create variables for them. Let's create resource as JKS file and another one is string password. So for this, the value is this, and for the resource, copy the path, value, import the resource. Now let's build the SSL context. So I'm going to use new SSL context builder dot. Here I'm going to use low trust material with file and the password. So here I have the file which is jks file.get file, and for the password password.toChar, and we need to build it. Now let's capture this one as SSL context. Now as part of it, we need to handle a couple of the exceptions. So let's continue it. So I'm adding them into a throws clause. So once SSL context is built, I'm assigning as a final. Now we need to create SSL socket connection factory. So for that, new SSL socket connection factory, and here I'm using SSL context, and here I'm saying no need to verify the host name, no host name verify, and I'm calling the instance. Assign it as a final. All we need to do is we need to use this socket factory to create HTTP client. Now let's create the connection manager. Final HTTP connection manager. New full HTTP connection manager build dot, and then we are going to create it here. And while creating it, we are going to set SSL socket factory, which was created SSL connection socket factory, and we call build. Let's reformat it. All we need to do is use this HTTP client manager to create HTTP client. Final closable HTTP client is equals to HTTP clients dot custom dot set connection manager dot build. Now we have the HTTP client. Set the HTTP client at the REST template. So let's access the REST template. This dot REST template dot get REST template and get the request factory, which is nothing but the client request factory. On this client request factory, we need to set this HTTP client. To set the HTTP client, we need to cache the request factory into HTTP client factory. HTTP components client request factory, we need to factory is equal to request factory, and we need to typecast it. After typecasting it, we need to set HTTP client which was created. So let's make this one also final. Format the code. Let's revisit what we have done. We have created a SSL context, and we use the SSL context to create socket factory. We have used SSL connection socket factory yet HTTP client connection manager, and we used the connection manager to create HTTP client, which is a closable HTTP client, and we set this HTTP client on the client HTTP factory, which was extracted from the REST template and typecasted into HTTP components client HTTP request factory. We have built everything, so wrap everything into a try catch and remove the throws from here. I'm going to surround with multi try catch, and let's remove this comment. Now let's run the test cases. Now we got an error from JUnit that it cannot set the before all because we have to set this one. If we need to use any of the before all, it must be static, but we don't have the static one. So that's the reason we need to set test instance, and we need to set the lifecycle as class. So let's add the same annotation, test instance, and I'm going to set as a class level. Save the changes and rerun. Now the test case has been passed. That means the JKS file is been used, and when the REST template is called, then it is using SSL context, which we set it up at the REST template. Let's rerun all of them. I'm rerunning all the test cases. Now if you see it, all the test case has been passed. So this is how we are going to secure our REST API using the Java key store.